let's study 10th standard ICSE physics numericals of chapter 3A. Students, in exercise 3A, cancel the second sum, it's very easy, and mark the following sums as IMP: the 7th sum, the 8th sum, and the 10th sum. Now in the 5th sum, a crowbar is used whose total length is given, the load is given, and the distance of 1 meter from the sharp edge, which is the fulcrum, and his hand. So this seems to be the effort arm. So if the total length is 1.5 meters and the effort arm is 1 meters, that means the load arm will be 1.5 minus 1, 0.5 meters. With this information, we can solve everything which is asked to be. First of all, alpha, they've asked us to draw the diagram. So here's the diagram. The total length of the crowbar was 1.5 meters. As given, the effort arm is 1 meter. That is the distance between the fulcrum and the hand. Load is given, effort is asked. Also, the load arm will be 1.5 minus 1, that is 0.5 meters. Which class of lever is this? This is class 1 lever because fulcrum is between the load and the effort. Now the calculation part, that is Charlie. So this, whenever you cancel a big part of your answer, make sure you box the cancellations. Presentation is very important in the board exams. Now, as I said, load arm is 0.5 and effort arm is 1. So we can find the mechanical advantage by the formula effort arm upon load arm, which is 2. Yes, crowbar is a force multiplier, so the mechanical advantage had to be greater than 1. And of course, in such sums, you always assume efficiency as 100%. Now next, they want the effort to be applied. Now, clearly, effort will be less than the load because it's a mechanical advantage greater than 2. Using the formula, we can calculate the effort to be 37.5 kgf. Now in question 6, a pair of scissors is used to cut a piece of cloth by keeping it at a distance of 8 centimeters from its rivet. Rivet is a fulcrum. So this is the load arm. And by applying the effort of 10 kgf by fingers at a distance of 2 centimeters from the rivet, so this is the effort arm. So though the diagram need not be drawn, but if you draw it, it becomes easy for us to visualize the machine and solve efficiently. All the data have been written. Now mechanical advantage is effort arm upon load arm, which is 0.25. We need to remember, even before solving, that scissors are a speed multiplier. So obviously the mechanical advantage will be less than 1. And next, we can use this mechanical advantage to calculate the load offered by the cloth, 2.5 kgf. That means you'll have to apply an effort of 10 kgf to overcome the load, the resistance offered by the cloth of just 2.5 kgf. That's okay. At least we are getting a gain in speed while cutting the cloth. And it is a speed multiplier. They've asked in the question what kind of a machine it is. Now in the 7th sum, they've given a 4 meter long rod of negligible weight is supported at a point 125 centimeters from its one end. So that is the position of the fulcrum. And a load of 18 kgf at a point 60 centimeters from the support on the shorter arm. So this seems to be the load arm and this is the load. So load and load arm are given. Now in alpha, if a weight W, that is the effort, is placed at a distance of 250 centimeters from the support. Support means the fulcrum on the longer arm, that is the other side. Find W. So this is the effort arm. So if you draw a diagram, load is given, load arm is given, effort arm is given, and effort is asked. Now interestingly, the total length of the rod being 4 meters is of no relevance in this sum. Also the position of the fulcrum being 125 centimeters away from one end is also of no use. The only thing that matters is the distance from the fulcrum of the load and the effort. That is the load arm and the effort arm. So either we can use principle of moments to solve this sum, that is total anti-clockwise moment is equal to total clockwise moment in equilibrium, or we can use the principle of levers, which is the same thing. Load into load arm is equal to effort into effort arm. Substitute all the values and get the value of the effort as 4.32 kgf. So W is equal to this. That is part A. Now in part B, they have given the weight and asked its position. So let's draw another diagram for that. This time, the effort, that is the weight, is given and the effort arm is missing. So we'll assume it to be x centimeters according to principle of levers or law of levers. Again, substitute and get the answer as 216 centimeters, which can also be written as 2.16 meters. And in Charlie, they've asked the class of this lever. Clearly, the fulcrum is between the load and the effort, so it is of class 1. Now in question 8, the lever's total length is given, its load arm is given, and the effort arm is given. Whenever effort arm is greater than the load arm, and the effort arm is in fact equal to the length of the lever, if you draw such a diagram, which is asked in the Bravo question, it would look like this. The load arm is 5 centimeters and the effort arm is 9 centimeters, which is the entire length of the lever. So clearly, this is of class 2 type, as asked. Next, they've asked us to calculate mechanical advantage and velocity ratio, and the formula is effort arm upon load arm, which gives us 1.8. Now we are here, they have assumed that the efficiency is 100%. But in delta, they have asked what would be the mechanical advantage and velocity ratio if the efficiency becomes 50%. Now we know that velocity ratio doesn't depend on efficiency, so that will continue to be 1.8. But if the efficiency is 50%, that means mechanical advantage will be halved. That is, mechanical advantage will become 0.9. But we can show the working. First write the formula, percent cancelled, and that's the final answer. Now in the 10th sum, the diagram is given. A is the center of gravity of the wheelbarrow, which itself has a mass of 15 kgf, and it carries a load of 30 kgf. The first question is, what is a load arm? The fulcrum is B, and the load can be assumed to be focused on point A. So the load arm is AB, that is 20 centimeters. Next, what is the effort arm? Effort is applied at point C. That's where we keep our hands while lifting this or pushing this wheelbarrow. So the effort arm is actually BC, that is totally 60 centimeters. So that's the effort arm. Next, what is the mechanical advantage? Mechanical advantage is effort arm upon load arm, which is equal to 3. So clearly it's a force multiplier. And what is the minimum effort required to keep the leg just off the ground? This is the leg. Simply speaking, what is the effort required to lift this load? So we use a formula here. That is, mechanical advantage is equal to load upon effort. But if you read the question carefully, the load is not just the 30 kgf of the goods inside the wheelbarrow. We also have to lift the weight of the wheelbarrow. So that should be added to the load. So the total load to be lifted is actually 15 plus 30, 45 kgf. So keeping that in mind, the effort comes up to 15 kgf. If the wheelbarrow was lighter, as light as possible, then the effort required would have been even lesser. A fire tongs. Tongs is plural and we use yeah, because tongs are always in pair, like a pair of scissors. Anyway, back to physics. It has its arms 20 centimeters long. It is used to lift a coal of weight 1.5 kgf by applying an effort at a distance of 15 centimeters from the fulcrum. Find the mechanical advantage and the effort needed. First of all, we should draw the diagram because it makes it easy for us to visualize the sum and solve it. Load will obviously be at its tip far away from the fulcrum. So the load arm is equal to the length of the arms, which is 20 centimeters. The effort will be applied between them because this is a class 3 lever. Effort arm is 15 centimeters. So mechanical advantage comes up to 0.75. Clearly, it's not a force multiplier, it's a speed multiplier. Now, using the other formula of mechanical advantage, load upon effort, we can find the effort required to lift this, which is 2 kgf. So how to solve decimal fractions? Well, get rid of the decimals first. 2 decimals. So into 100, shift 1, 2, shift 1, 2. That becomes 150 upon 75. And then you can reduce it to 2 kgf.
Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.